Let's think of what a function is. Essentially, a function is a machine that takes in inputs, or x values, and spits out some outputs, or y values. For example, if our machine was called x squared, then I can input x values such as 2, minus 4, and 20, and it will produce outputs of 4, 16, and 400. Actually, for this machine, I can put all the numbers from minus infinity to infinity into it, and get some result for each. Now let's recall what the domain of a function is. The domain consists of all the x values, or inputs, that I can put into a function. The only x values that we do not include in our domain are the ones that break our function. So as we input numbers from negative infinity to infinity into our function, we have to make sure we don't put in any numbers that accidentally break our machine or our function. So what does it mean to break our function? Well, in this class, remember, we are only working with the real numbers. That means no imaginary or complex numbers are allowed. So if we input some x value that produces an I or a negative under the square root, we have to restrict it from our domain. The second way that we can break our function is if our x value produces a 0 in a denominator. Remember, we can never divide by 0. Whenever we are trying to identify the domain of a function, we always start with the assumption that all numbers from minus infinity to infinity work. Then we go through and check to see if there are any numbers that break our function by violating either of these two rules. To find the domain, we have to check to see if any real number violates either rule. Ask yourself, do you see any radical sign? Well, no. Then we can't violate the first rule. Then ask yourself, do you see any fractions? No. So we can't produce a 0 in a denominator. So we can't violate the second rule either. Since neither rule can be violated, there does not exist a real number that needs to be removed from our domain. Thus, our domain is the set of real numbers from minus infinity to infinity. To find the domain, we have to check to see if any real number violates either rule. Ask yourself, do you see any radical signs? No. Then there's no way we can violate the first rule. Now ask yourself, do you see a fraction anywhere? Yes. So we have to be careful. We have to exclude any x values that make our denominator 0. So we don't want whatever x makes this statement equal 0. If x were minus 1 over 3, the denominator would be 0, so we must remove it from our domain. Therefore, our domain consists of every real number from minus infinity to minus 1 over 3, then from minus 1 over 3 to positive infinity. Notice how I use parentheses instead of brackets here. On a number line, it looks like this. To find the domain, we have to check to see if any real numbers violate either rule. Ask yourself, do you see any radical sign here? Yes, so we have to make sure to avoid violating the first rule. Do you see any fractions here? Yes, however, the denominator does not have any x's, so we don't have to worry about some input violating the second rule. Let's now look at how to avoid breaking rule number 1. We want to make sure that everything under the radical is greater than or equal to 0. This means for our domain, we only want the numbers less than and equal to 2 over 3. On a number line, it looks like this. find the domain, we have to check to see if any real number violates either rule. Ask yourself, do you see any radical signs? Yes, so we have to make sure to avoid violating the first rule. Do you see any fractions? Well, yes, so we also have to make sure to avoid violating the second rule. The first rule says that we want whatever is under the radical to be greater than or equal to 0. But the second rule says that we don't want the value to be 0 either. So we must take away this equal sign from our inequality. Now we just solve for x. This means that we want all the numbers greater than 2 and less than minus 2 in our domain. On a number line, it looks like this.